Jungle. Audio Jungle. Audio Jungle.
Hello, Dangal greetings everyone. So I will be discussing to you the main class for the robot assembly system. So this class execute all the objects and uh, the method that are called to operate in the system. So first things first, we have package named Composition Final Quiz. So this package stores the classes used in the system. So these classes are the main class and the robot class. And this also helps organize related classes and prevents naming conflicts. The next one, we instantiated an object robot named Optimus Prime. So this object has a model number OP-001. So this object demonstrates how the composition relationship works, where the robot object is composed of different parts such as head, torso, arms, legs, and weapon. Then we create the parts for the robot. So these parts are the inner classes for the robot class. We have the head, torso, arms, legs, weapon. So these are the components to run the operation for the robot. So by declaring these classes as the inner classes inside the robot class, so we can ensure that all components are logically owned and managed by that object. And a method assembled from the robot object named Optimus Prime. So this method has a parameter for the parts, which are the head, torso, arms, legs, and weapon. So by using this method with its function that will be discussed later, we will achieve making these parts to function as one. And a method power up also from the robot class named Optimus Prime. So this power up method will be used its function to rely or to put power on the other classes, or simply saying that this method with its function or the other methods in the robot class will be activated using this. So the parts rely on power supply to achieve the function of each method. And finally, the line that will print out the famous line of Optimus Prime, which is Autobots Rollout. And that is the main class. Then the robot class will be discussed to you by Mr. Alzona.
So, greetings everyone and a blessed day. I am Justin Alzona and this is our project about the composition in Java OOP lesson. So as you can see here, we have here a UML diagram and we have a parent or base class named robot and it is a public class that has a many parts. So imagine in the industry where you buy a certain product such as robots, cars that can transform. So it has multiple parts. Am I right? So the same goes with this concept. We have here a robot that has many parts. So this has a head, torso, arms, legs, and weapon. So in a short manner, all of these are the parts of the robot. So the robot has a head, which technically exists. It has a torso, arms, legs, and weapon. So this arrow, which has a filled diamond, signifies that this class is belongs to the robot class. So meaning robot composed of head, torso, arms, legs, and weapon. So these are called composition or the art of the class to have or gain a nested class. So that's basically it. And our class here, robot, I will explain it to you personally, and those remaining classes will be explained by my groupmate. And also this special purpose robot assembly line class. So let's go here on our main class, which is the robot.java. So as you can see, it is the parent-based class, and there are other classes inside this robot class. So that is composition. So our robot class, according to the UML, has many kinds of attribute. It has name, which is a string, a model number, also a string. Then it has classes or object as a attribute, which is head, torso, arms, legs, and weapon. And then the methods, it has assemble, then power up method. So we have here a public constructor. Again, the constructor, we have tackled it on the earlier lesson. The constructor are used from the word itself to construct a certain or specific object. So we have here a robot class. So when we call the robot class in the main class and signifies it or instantiate it, it will create a new object, which is the robot class. And it has a parameter or argument, the string name and string model number. Then we have here the getters and setters, and I know you know it, which signifies method to get the name because it is encapsulated here in attributes because it is private. It is not accessible to any other classes. Then we have here the methods. So we have here public void assemble. It has many arguments, which is head, torso, arms, legs, and weapon, which is the part of the robot. So when we call this method, it will assemble the entire robot and just the simulation. It is assembled ready for battle. And then when we click the power up, so the robot will power up. So it is just some sort of simulation. So technically that's it, and you will see the further explanation by my groupmate. So thank you so much and God bless. So double greetings everyone and a blessed day. I am Justin Alzona.
Good day, Danga greetings. I am Chelsea Urbina, and I am going to explain one of the inner class or nested class in our robot.java, so which is the head class. So as we can see here, we have two attributes. So the eye color and also the sensor type. So let me explain to you what this will do. So for the eye color attribute, so it stores the visual appearance of the robot's eyes, such as red or blue. So this attribute can be used for design customization or functional identification. And the second attribute is sensor type. So the sensor type defines the technical capability of the head's sensors, such as thermal, or night vision, so it determines how the robot perceives its environment. So for our constructor, here we have, so for our constructor, it is parameterized with two parameters. So the eye color and sensor type. So this will set the values of the two attributes once we instantiate an object. So we also have getters and setters method. Here we have get eye color and set eye color. So for the get eye color, it will retrieve or update the robot's eye color, and the set eye color will access or modifies the eye color as well as the sensor type. It will retrieve the sensor type, um, and for the set sensor type, it will access or modify the sensor type attribute. So let's go on our code so that I can show to you the two other methods that will be functional for the whole program. So we are now here in our code. I've already explained the attributes, the constructors, and also the getters and setters for this class. So I will now explain to you the two significant methods, which is the activate and the scan area. So let me explain first the activate method. So the activate method This simulates the robot turning on its sensors and visual systems. As we can see in the first um, line, so activating sensors and visual systems. So in the try catch, it means that we are pausing the program for 3 seconds. So to make it feel like a real robot is processing. So after the pause, then it will print sensors and visual system activated successfully. And for the scan area method, so this method simulates the robot checking the area for threats. So it prints sensing area from threats. So just like before, we use the try catch method, and just like before, it will pause for 3 seconds to make it feel realistic. So then after that, it will print the area is clear. So that's all. Thank you.
Greetings everyone, my name is Leslie Ann M. Madula from 2ITT, and for my part, I will be explaining to you the composition class of robot named Torso. In my class, we simply have one attribute that asks the power source of the robot. Then, on line 156, we then implemented a constructor with one variable in the parameter so that we can use it in the main class right here in line 8, and then inside the parameter is the string of the power source of the robot. Then after that, we implemented a getter and setter method simply to get the value of the power source and set the value of the power source. Then next we have the public void activate. By calling this method, we are printing out this line right here, like robot name, the name of the robot would activate the power source from the power source that the user had placed, or like the program had placed inside the constructor. And before printing this out, we are gonna try to put like a delay in the program output, like this thread dot sleep 3000. It meant that there's like 3 seconds delay before printing this line, and then if there's an error it would print this, but nonetheless after 3 seconds it would print power is generated successfully. And disclaimer for our professor, we had already been taught about this thread dot sleep back in first year when we were being taught about Java Swing. So yeah, that's all for me. Thank you.
Hello, Dangal greetings. I'm Elrob Jan Irabon, and I will be explaining to you the ARMS class. So this ARMS class is one of the subclasses of robot class. So going back to the ARMS class, we have here a single attribute, which is the private int strength level. So this attribute stores the value for the strength level of the arm. Then next one, we have our constructor for this class, public arms, with its single parameter, which is our attribute strength level. Then also we have here get strength level and set strength level as our set and get method. Then just like other subclasses, we have activate method. So public void activate. So this method do the printing out the name of the robot plus the arms extracting power level, which is the function for this class. Then before that, the strength level, the value for the strength level, you can see here in the main class, we initialize a value for the strength level, which is 100. And going back, we use try catch block. So to try to run the thread.sleep 3000, so meaning this will delay the process of printing this function for this class. Then a catch to catch the error if there is an error. Then finally, we have here it will print out the text power is extracted successfully ready for combat, which means the power is extracted successfully. So that will be my part for this presentation. Thank you.
Dangal greetings everyone, my name is Radin Rio Maloles, and today I'm going to walk you through a specific and very important part of our Java robot program, which is the legs class. The legs class play a key role in our robot mobility and movement. So let's break down and how it works, why it exists, and how it connects to the overall functionality of the robot. The legs class is defined as inner class inside the robot class. This means that it is nested or written inside the outer robot class. Since a robot logically has legs, this is great use of a composition in object-oriented programming. Composition means we are building a complex objects like our robots by combining simpler parts such as head, torso, arms, legs, and weapon. Each part of this is separate class inside the main robot class. Inside the leg class, we have a private field, which is the private int mobility level. This field represents how fast or mobile the robot legs are. Think of it like a speed rating. A higher number could mean the robot moves faster or has a better agility. So we use a constructor to initialize this value. So when we create the legs object for our robot, we pass in a value, for example, 100 to define its speed or capability. We also have a methods to get and set the mobility level. Note that this method get strength level is a bit misleading. It should be ideally be named get mobility level for clarity, but it still work functionality. It returns the value of mobility level. Setter and getters help maintain encapsulations, giving off direct access to the variable. We control how it access or modify. The activate methods, when the robot is powered up, the activate method is called for the legs. It prints message saying it's extracting the speed level. Then it stimulates a delay using thread.sleep 3000, which pauses the program for 3 seconds like a loading animation. After the pause, it prints a confirmation that mobility is enabled and the robot is ready to move. So, in the main class, we create a legs objects like Optimus legs, and we give it mobility level of 100. Then we assemble the robot using this part along with head, torso, and arms weapon. Later, when the power-up method is called, it's activate on each part, including the legs. This shows the legs are fully integrated in the robot startup process, and without them, the robot wouldn't be able to move or travel. So to sum it up, the leg class is an inner class of the robot using composition. It contains a mobility level attributes that controls how mobile the robot is. It has a getter and setter methods maintaining encapsulations. The activate method simulates enabling movement with visual feedback and delays. It works together with other parts like head, torso, arms, and weapons to bring a robot to life. So, thank you for listening. I hope this explanation helped you understand the legs class better and how it contributes to building a fully functioning robot in Java. Thank you. Let's proceed to the next reporter.
Dangal greetings everyone, I am Shania Magda and today I'm gonna explain to you how we make the class weapon inside the robot class. So first, we declare the class named weapon, so it is nested inside the robot class, meaning it can access the robot's data. So here we declare a private variables which are the string weapon type and private int power level. So dito tayo nag-store ng type of weapon and the power level of the weapon. And then here we declare a class constructor. So it is the constructor of the weapon class which is public weapon string weapon type int power level. So it is called when you create a new weapon and it has two it has two arguments which are the string weapon type and int power level. So this weapon type and this power level, so it assigns the value as in to the class weapon type variable and the power level assigns the power level value to the power level variable, which is here in the main class we created a new weapon uh, which has iron blaster weapon type and 5000 power level. So for the getter and setter, so again the uh, getters is gets the value of the weapon type and the power level, and then the setters set or update the value for the weapon type and power level. So next is the public void activate. So this stimulates the weapon being activated. So it is called when the robot uses the weapon. For the 268 line, this uses the robot name from the outer class, this robot, that name, and display the message that the weapon is starting up. And then for the line 269, it displays the power level as part of the activation message. Next is the try catch. So this try or the try condition, it helps to give the program 3 seconds delay kapag kapag niran mo siya. So it pauses the program for 3 seconds to stimulate the activation time. So this thread that sleep 3000, it means 3 seconds. And for the catch condition, if something interrupts the pause, like the thread issue, it prints the error. And then for the line 276, the system.out print line weapon is ready. Let's destroy the enemies. So this prints the final message that the weapon is fully ready for the action. So that is all for the weapon class. Thank you everyone.
Hi again, I am Chelsea Urbina, and let's dive in our code. So I will now explain the robot assembly line class. So it is one of the inner or nested class inside our robot Java. So inside this class, we only have one method, and that is the build robot method. So as we can see, the return type is robot. It means we are going to return an object, and it has multiple parameters, which it have two strings, which is the name and the model number, and multiple objects, which is the head, torso, arms, leg, and weapon. So here in our method, we instantiated the robot. So robot is equals to new robot, name, and model number. So, and also after we have instantiated the robot, so we use the robot instance. So we have called the method inside it um, and return the head, torso, arm, leg weapon. It means we are setting these objects for our robot. And after that, we will now print the robot's name and then assembled Autorobots Let's Roll. So, and then it will now return um, the full set object robot.